In this video, we will try to understand how to find out the boiler efficiency and equivalent evaporation per kg of fuel burnt. Now, this question we have taken from Pune University Thermodynamics question paper of May 2008 and question number is 5B. The problem statement is 5500 kg per hour steam is produced at a pressure of 76 bar in a boiler with a dryness fraction of 0.98. The temperature of the feed water is 51 degrees centigrade and the amount of coal burnt is 650 kg per hour, having calorific value of 35,000 kilojoule per kg, and we have to determine the boiler efficiency and equivalent evaporation per kg of fuel burnt. So first we'll write down the data which is given to us. So mass of steam is given as 5500 kg per hour. Pressure at which the steam is generated in the boiler is 76 bar. Dryness fraction is 0.98. Then temperature of the feed water is 51 degrees centigrade. Mass of fuel burnt is 650 kg per hour, and calorific value of the fuel that is burnt is 35,000 kilojoule per kg. We have to find out the efficiency of boiler and equivalent evaporation in kg of steam per kg of fuel that is burnt. Now, as the feed water temperature is 51 degrees centigrade, we have to find out the value of saturated, the specific enthalpy of the saturated water, that is HF, at 51 degrees centigrade. Then, as it is given that the pressure of the steam that is generated is 76 bar and dryness fraction is 0.98. So, as dryness fraction is given, it is a wet steam. So, the formula for the wet stream is HF plus X HFG. So these values we have to take at 76 bar, that is the values of HF and HFG. Then using these particular values we have to find out the boiler efficiency. But before that, let us see the values that we are going to take from the steam table. So here we have shown the part of the steam table on the temperature basis steam table. The steam table that we have used is having the temperature values of 50 and 52. But in our case it is given as 51, so it will be the average value of these two. So we have to find out HF, and the value of HF is given by these two values. So this is temperature, then pressure, then HF, HFG, HG, and so on. So we are interested in this particular two values, so take the average of these two. So it is 209.3 plus 217.7 divided by 2, and that value comes out to be 213.5 kilojoule per kg. So that is the value of HF at 51 degrees centigrade by interpolation. Similarly, we have to take down the values of HF and HFG at 76 bar. So again, at 76 bar, the value of HF is 1297.6. So that we have written over here, and value of HFG, that is the specific enthalpy of evaporation, is 1467.9. That is also written over here. So HF is 1297.6, dryness fraction that is given is 0.98, and HFG is 1467.9. The value of H2, that is the specific enthalpy of the steam generated, is wet steam that is generated, is 2736.142. Now boiler efficiency is output divided by input, and the output is calculated in terms of the amount of steam that is generated. So it is mass of steam into H2 minus H1, that is the heat that is required to raise that particular steam, divided by the input, that is nothing but the heat that is supplied by burning the fuel. So it is mass of fuel into the calorific value of fuel. So substitute the required values over here. So mass of steam is 5500, H2 is 2736.142, H1 is 213.5, mass of fuel burn is 650, and calorific value is 35,000, and multiplied by 100. So the efficiency of the given particular boiler arrangement is 60.986%. Now we have to find out the equivalent evaporation from and at 100 degree centigrade. So it is nothing but the amount of steam that is generated per kg of fuel burnt if the boiler is operated from and at 100 degree centigrade. So from and at 100 degrees centigrade, it means that temperature is remaining constant, and so we have to take into consideration only the latent heat, and that value is to be taken at the atmospheric pressure. So we are operating this particular boiler at the atmospheric condition, and therefore so our original or actual boiler is operating at 76 bar, but this particular hypothetical boiler we are going to operate at the atmospheric condition and only from and at 100 degrees centigrade, and therefore we have to take into consideration only the latent heat part in the denominator. So mass of steam multiplied by H2 minus H1, that is the amount of heat required to raise the steam, divided by mass of fuel into the latent heat or specific enthalpy of evaporation at atmospheric pressure or at atmospheric temperature corresponding saturation temperature of 100 degrees centigrade. So if you observe the steam table, then the value of HFG at 100 degrees centigrade is 2256.9. So that we have mentioned over here. And now just substitute the values. So mass of steam is 5500, H2 is substituted, H1 is also substituted over here, mass of fuel is 650 and multiplied by 2256.9. So the given particular boiler, it produces 9.458 kg of steam per kg of fuel if it is operated at the atmospheric condition and if 1 kg of fuel is burnt. So that is the meaning of this particular equivalent evaporation. Thank you very much for watching.